Have you ever been involved with a construction project that encountered utilities that nobody really knew were there? I'm sure that's happened to just about everybody that's worked in the highway industry over the last quarter century or so. Hello, I'm Bill Wiesman, Director of FHWA's Office of Engineering, and I'm here to introduce you to a video that will describe a proven new process for taking care of this age-old problem. The solution is called Subsurface Utility Engineering, and it indeed is a proven solution to this problem, and it will help us ultimately save time, save money, and produce a better product for the American taxpaying public.
Virginia Department of Transportation has been applying subsurface utility engineering to its transportation projects for over 10 years. We have documented savings of $7 for every $1 spent to locate potential utility conflicts.
We estimate that we save $18 for every dollar spent on subsurface utility engineering.
In Pennsylvania, the project owner can be held legally responsible for the accuracy of the information on the bid documents. Consequently, we want a competent professional to obtain that information for us.
Subsurface utility engineering values have gone far beyond the documented dollar savings. It's really meant keeping our projects on schedule.
We have tremendously reduced the risk of delay claims, extra work orders, damages to utilities on projects where we've used comprehensive subsurface utility engineering.
What is subsurface utility engineering? Quite simply, it is a proven process that incorporates new and existing technologies to accurately map underground utilities during the development of future construction projects. It encompasses several separate activities, including designating, locating, surveying, and mapping, all of which are performed under a professional program of data management. The essence of subsurface utility engineering is simple. Before an engineer designs a project involving excavation, the engineer should know what structures and conditions are beneath the earth and where they are in 3 dimensions. Such structures are usually utilities, but may include underground storage tanks, septic fields, and other things. Before the development of subsurface utility engineering, the standard methods to determine the location of underground structures were inefficient, risky, and costly. Today, because of the availability of subsurface utility engineering, both horizontal and vertical locations are available quickly, accurately, and inexpensively.
Subsurface utility engineering is the answer to many of our utility problems.
Subsurface utility engineering involves the collection of underground utility data and the use of that data by the right parties at the right time. Its major components, designating, locating, surveying and mapping, and data management, can be defined in terms of quality levels of information. Quality levels may be thought of as degrees of risk, or how much information is really needed before planning, designing, and constructing a project. There are 4 quality levels. Quality level D is the most basic and the least desirable level of data. It comes solely from available utility owners' information. It has application for planning purposes such as selecting routes and estimating utility relocation costs. Even though quality level D information may provide an overall feel for the congestion of utilities, it is highly limited in terms of comprehensiveness and accuracy for design purposes.
In Maryland, we have used quality level D since 1988 in the planning phase of our projects. This is usually adequate for route selection. But make no mistake, this level of data is not adequate for design purposes.
Historically, Quality level C was probably the most commonly used level of information for design purposes. It involves supplementing quality level D information with an above-ground survey of visible utility features, such as manholes or valve boxes.
Looks like they've paved over the valves.
But utility records and topside survey data are just not enough to provide an accurate picture of where subsurface utilities are located. Professional studies have shown a 15 to 30% error or omission rate with this approach. So quality level C should rarely be used for design purposes when underground utilities are present. Quality level B is the first level where subsurface utility data departs from traditional practices. It involves supplementing quality level D information with designating, surveying, and mapping. Designating is the use of surface geophysical prospecting and remote sensing technologies to determine the existence of underground utilities in plan view. The use of this information allows decisions to be made during the preliminary design phase of a project on where to place storm drainage systems, footers, foundations, and other design features in order to avoid conflicts with existing utilities. Slight adjustments in the design can produce substantial cost savings and increase safety by eliminating utility relocations and moving excavation work away from existing utilities.
A total of 66 feet from that offset.
Quality level B data is invaluable in designing our construction input. It also provides quick access to data during an emergency.
Quality level A information is the highest level of accuracy currently available. It involves adding locating to the quality level B information. Locating is the exposing of buried utilities to determine their precise horizontal and vertical position in plan and profile view. The use of non-destructive vacuum excavation equipment and other technologies eliminates damage to underground facilities, damage traditionally caused by backhoes. The small test hole involved reduces impact on traffic. The test hole itself is about 20 by 20 centimeters at the top, which reduces pavement damage. By knowing exactly where a utility is positioned in 3 dimensions, the designer can also make small adjustments to the final design elevations, horizontal locations, or structure types to further avoid relocating utilities or digging near them. The engineer also gets critical data about utility conditions, size, material types, soil conditions, and other important information.
In North Carolina, we have yet to realize all of the quantifiable benefits of subsurface utility engineering. But we feel confident that when all the benefits are analyzed and tallied, they will substantially exceed the $1.5 million we have spent so far on our program.
The bottom line is control and accountability. When you hire a subsurface utility engineer, you buy judgment and accountability. That means prudent engineering decisions. You control your project schedule. You build your projects faster and at lower cost. How a state or municipal public works agency engages a subsurface utility engineer may be as important as whether they engage one at all. Why? Because inaccurate subsurface utility data is probably more dangerous and inefficient than none at all. A registered staff professional must review subsurface utility engineering data and deliverables. He or she must seal the appropriate work product and be individually and corporately responsible for the accuracy and reliability of the data delivered. With no professional review or sealing, no one is responsible for the information. Remember, accountability is the key. Professional liability insurance that underwrites a provider's operations is essential. The claims record of the provider is also important, since it is indicative of the quality of that provider's services. Without professional liability insurance, there may be no money to back a provider's accepting responsibility. Specific written quality assurance procedures that are applied to each and every project also are critical. Without written procedures that are universally applied, the data may not be accurate or reliable. Procuring agencies should specifically review these procedures and insist on their use. Subsurface utility engineering is an interpretive science. The amount of experience a provider has is directly related to its ability to interpret the wealth of information that goes into a subsurface utility engineering project. The more experienced the provider, the less chance for misinterpreted data. No one piece of equipment can provide all necessary subsurface utility engineering data, so a provider needs to have experience in a wide range of equipment and their application to different project conditions, configurations, and so forth. A subsurface utility engineering provider must be able to work within an agency's specific CAD requirements. Experience in different systems and particular experience in a specific system will improve a project's efficiency. Subsurface utility engineering is often applied when project schedules are tight. Check your provider's record of timely performance. Remember, time is critical when you are trying to get your project out to bid. Subsurface utility engineering is multifaceted and draws from many areas of expertise. A provider must have multiple disciplines at its disposal to address the multitude of problems confronting a project. At a minimum, geologists, surveyors, and engineers are needed. Bottom line, untimely and inaccurate utility information is often worse than no information at all. Agencies need to take the lead in the procurement process to assure they get the best quality services at fair and reasonable prices. Many ask, why should an agency pay for these services when utility companies may be legally responsible for the information? First, it is the agency's project, and they should take responsibility for the information you need.
Utilities find it difficult to respond to our project schedules. By MDOT contracting these services, we get the control, accuracy, and timeliness that we desire.
Highway agencies and utilities both benefit from using subsurface utility engineering. In many states where it is being used, the highway agency pays for it, generally as a preliminary engineering activity. But in a few states, the utility pays. And in some states, the highway agency and utilities share the cost. No matter who pays, the party with the greatest incentive for getting timely and accurate information should retain control over the subsurface utility engineering work.
We have considered using utility companies to locate and designate their facilities, but we found that this is just not practical or cost-effective. On this issue, we could not justify spending a dime of administrative cost to receive a nickel's worth of value.
Subsurface utility engineering is not limited in its application to roadway projects. In fact, getting accurate and reliable subsurface utility data is appropriate whenever there is a significant likelihood of a backhoe, piling, or anything else conflicting with an underground utility.
It's especially beneficial to have accurate utility information at the start of design to avoid future utility relocations and their associated costs.
Apart from all the other good news about subsurface utility engineering, consider this. When you apply it, you get lower bids.
On one job, we applied it, and our bids were $400,000 lower than we anticipated.
CH2M uses subsurface utility engineering on a wide variety of our projects, involving such things as water, wastewater plants, environmental remediation, and the wide range of our transportation infrastructure. We find that subsurface utility engineering provides both value and quality to the type of work that we do for our clients.
In the past few years, you've seen on the evening news the effects of excavation damage to pipelines and other buried systems, impacting the environment and public safety. Many of these incidents are the direct result of poor information on the location of those systems. At the National Transportation Safety Board, we're promoting subsurface utility engineering for one reason and one reason only. It protects pipelines, the environment, and most importantly, people's lives.
From an academic perspective, subsurface utility engineering just makes sense. You're able to shift the risk that's involved in the engineering and construction process of bad information to the party that's most able and qualified to accept that risk, and of course that party being the subsurface utility engineer.
Subsurface utility engineering applies anytime excavation will occur around underground facilities. Subsurface utility engineering saves time, money, and lives. Together, as leaders in the engineering, construction, and utility fields, we can improve schedules and lower project costs. Spread the good news about subsurface utility engineering. It's a proven solution.